So two of the things that we're going to look at next involving transformations has to do with what are known as linear transformations and also some different things with combining two different sets of random variables together. So two of the things just to keep in mind involving linear transformations, and that is that whenever you are adding or subtracting a constant to a set of data values, the mean and the measures of center will change by whatever you add or subtract by, but the spread or the standard deviation will not. And then also, when we're talking about multiplication and division, that remember multiplication and division affect both the mean and the standard deviation. So in terms of some different things with what are known as linear transformations, this example here is a pretty good one in that respect. So the question here says, one brand of bathtub comes with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature, which we'll call in this case X, will be follows a normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. And the question here says to find the random variable y to be the water temperature in degrees Fahrenheit when the dial is set on baby safe. Find the mean and standard deviation of y. So according to the formula here, if we're converting Celsius to Fahrenheit, what we have here is the formula y equals 9/5 x plus 32. We could also write this in the form of y equals 32 plus 9/5 x, where the mean of y, in this case, would be, we would find that by, if we're converting from Celsius to Fahrenheit, we would take the value of the temperature here, okay, which would be 34 degrees Celsius. We would times that by 9/5 and we would add 32. And the reason that we would do that is because the mean is affected by both multiplication and also is affected by adding and subtracting. So the new temperature here, the mean of the new temperature in Fahrenheit would be 93.2 degrees Fahrenheit. Whereas with the standard deviation in this case, so here's the standard deviation in Celsius, it's 2 degrees. So if we're talking about the same formula, just remember that we don't want to put the plus 32 on the end of this. We don't want to do that because we know that the spread is not affected by adding and subtracting a constant to the data value. So all we want to do here to find what the new standard deviation would be in Fahrenheit is to just multiply the original standard deviation by 9/5, which would come out to be roughly about 3.6 degrees Fahrenheit. So that's just some different things involving linear transformations in regards to mean and standard deviation. The follow-up to this would be, according to Babies R Us, the temperature of a baby's bathwater should be between 90 degrees and 100 degrees Fahrenheit. Find the probability that the water temperature on a randomly selected day when the baby safe setting is used meets the Babies R Us recommendation. So in order to answer this question, if we're talking about probability here, what we want to know is what's the probability that the bath water is going to be between 90 degrees and 100 degrees Fahrenheit, knowing that, and we got this from the previous part, that the mean temperature in Fahrenheit is 93.2 degrees and the standard deviation would be roughly about 3.6 degrees. So what I'm going to do here first is find what the z-score would be for each one of these values, 90 degrees and 100 degrees. So that's the data value minus the mean divided by the standard deviation. Same thing over here. Data value minus the mean divided by the standard deviation. So these are the two z-scores that I get for each of those two values of x. And then the probability for this, if we did the normal CDF from negative 0.89 to 1.89, we would get roughly about 0.7839, which basically means we have a 78% chance that the water temperature meets the recommendation on a randomly selected day. So that's just some different things with what are involved or what are called linear transformations. So one of the other things we're going to look at in this lesson is how to combine random variables, meaning how do we take two different random variables and combine them together. So the question here says, let's investigate the result of adding and subtracting random variables. Let x equal the number of passengers on a randomly selected trip with Pete's Jeep Tours, and let y represent the number of passengers on a randomly selected trip with Aaron's Adventures. And we're going to define t as being x plus y. So in other words, what we're basically saying here is, what if these two companies, Pete's Jeep Tours and Aaron's Adventures, what if they basically decided to merge their businesses together? So this right here is the data that we have for Pete's Jeep Tours. So we know that Pete's going to expect on an average day 3.75 passengers on one of his tours with a standard deviation of 1.090, and here's the shape of the graph that goes with that. Then if we take this new set of data, which would be for Aaron's Adventures, and this is what we have for her, and this is the mean for how many passengers she expects on a randomly selected day, and this would be the standard deviation for that as well. So what we're looking to do here is how could we combine these two different random variables together? So if we were to do that, the question becomes how many total passengers can Pete and Aaron expect on a randomly selected day? And when we do that, we basically look at each of their expected values. So we would say that Pete expects 3.75 passengers, Aaron expects roughly 3.1 passengers. So if we take the total of both of their averages, what we could say here is together they would expect roughly 6.85 passengers per trip. And we can sort of generalize this with the following formula. So anytime you're looking to combine random variables, if we're looking at their expected values, if we're looking at their means, the simple way to combine their means is to take both of their each individual means and add them together. So the question here says, how much variability is there in the total number of passengers who go on Pete and Aaron's tours on a randomly selected day? To determine this, we need to find the probability distribution of T. So this right here represents, I'll show you this in a minute, what the probability distribution of T would be. So a key thing to keep in mind when we're talking about, if we're talking about spread, and this definition here sort of speaks to that. And what this says is, if knowing whether any event involving X alone has occurred tells us nothing about the occurrence of any event involving Y alone, then we would say that X and Y are independent random variables. And the key thing here is that probability models, especially when we're talking about combining, often assume independence of the two random variables. So when we're looking at combining random variables, especially when we're looking at the spread that's involved with combining two random variables, we want to make sure that the two random variables are independent of each other. So this right here represents the probability distribution for combining Pete's Jeep Tours and Aaron's Adventures. So this right here lists all the different combinations of passengers for Pete. This right here lists all the different possible combination of passengers for Aaron. And this is all the different total possible combinations of passengers that they could get and the corresponding probabilities that would go with them getting each one of those amounts of passengers on a randomly selected day. So this would be the mean, 6.85, and to find what the standard deviation would be for this, what we would have to do is take each data value, which in this case would be these numbers here. We would have to take each one of those numbers individually, subtract it by the mean, square it, and then multiply each of those by their corresponding probabilities. And if we do that, what we would get here is roughly 2.0775. This number here represents what the variance is of the two random variables. So this right here, or this value right here, is the standard deviation squared for Pete's Jeep Tours. This value here is the standard deviation squared for Aaron's Adventures. And the question here says, what do you notice about the variance of T? Well, if you notice, if you were to take these two values and put them together, this is what you would get for their sum. So if you square the standard deviation for Pete's Jeep Tours and you square the standard deviation for Aaron's Adventures, if you combine them, what you would get here is the standard deviation squared for combining the two random variables together. And this value right here is what's known as the variance. That's the standard deviation squared. That's the name that we give to that. So in terms of a formula, It says here, for any two independent random variables, and the key here to remember is that the variables have to be independent in order for this formula to work. So what we would say here is that the combined standard deviation squared is equal to the standard deviation squared of x plus the standard deviation squared of y. In general, the variance of the sum of the several independent random variables is the sum of their variances. So this standard deviation squared, once again, is just another word for the variance. So just a note here at the bottom, remember that you can add variances only if the two random variables are independent. So always make sure the random variables are independent and that you can never add standard deviations. The only thing that can be added is the standard deviation squared, which is the variance. So the example here says a college uses SAT scores as one criteria for admission. Experience has shown that the distribution of SAT scores among its entire population of applicants is such that the average value of their SAT math scores is 519 with a standard deviation of 115, and the average SAT critical reading score is 507 with a standard deviation of 111. So the question here says, what are the mean and standard deviations of the total score x plus y among students applying to this college? So the mean, simply put, is just adding the two means together. This would be the 519 here plus the 507. Whereas with the standard deviation, what I want to do here is, if the variables were independent, I would square each of these and add them together. But one of the things that we know is true is that SAT math and SAT reading scores are not independent. Because students who score high on one exam tend to score high on the other also, or low, and vice versa, you would say that these two variables are not independent. So hence, we can combine them, we can combine their means, but what we can't do is we cannot combine their standard deviations because they're not independent. So that's just one example there. Another example here would be kind of revisiting Pete and Erin's tours. It says earlier we defined X as the number of passengers on Pete's trip and Y the number of passengers on Erin's trip, and C the amount of money that Pete collects on a randomly selected day. We also found the means and standard deviations of these variables. So this right here is the mean and standard deviation for Pete's Jeep tours. Here is the mean and standard deviation for Erin's adventures. And here is the mean and standard deviation for the amount of money that Pete collects. So the question here says Erin charges $175 per passenger. If you recall, Pete was charging $150. And the question says let G equal the amount of money that she collects on a randomly selected day. Find the mean and standard deviation of G. So we're using this data value, these two data values here, knowing that she charges $175 per trip, or per person. So to find what the mean would be here, I would simply just take 175 times the 3.1, and that gets me, she would expect to collect $542.50 on any given trip. And then the standard deviation, I'm going to also multiply that by 175. So we would expect about $165.03 as far as the average amount of money that should differ from what the mean would be for this. So part B for this says to calculate the mean and standard deviation of the total amount that Pete and Erin collect on a randomly chosen day. So if we're going to combine their amounts that they collect, here's how much money Pete expects to collect, here is how much money Erin expects to collect, so this is how much total money they should expect to collect on a randomly selected day. So the standard deviation, assuming that Pete and Erin's tours are independent of each other, what we would want to do here is we would want to say that the standard deviation squared plus the standard deviation squared would equal the combined standard deviation squared. So this is what you get when you square the standard deviations and add them together. To find what the standard deviation is, I would need to take the square root of that value, which would be $232.31. So that would be what the combined standard deviation would be for the amount of money that they collect together. So the last question here, and it says a large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let X equal the number of cars sold and y equal the number of cars leased during the first hour of business on a randomly selected Friday. Based on previous records, the probability distributions of x and y are as follows. So these are, and we kind of did some different things with this previously in terms of the amount of cars that are sold in the first hour of a randomly selected Friday. We're now adding this to the mix, which would be the amount of cars that are leased in the first hour on a randomly selected Friday. So the question for this says first to find and interpret the value of t, meaning what is the, or find and interpret the mean of t, and t is defined as what x plus y would be. So if we took the two means and added them together, we would come out that be roughly 1.8. So what we would expect here is on average this dealership will sell or lease 1.8 cars in the first hour of business on Fridays. Then to compute the standard deviation, assuming that x and y are independent of each other, what I'm going to do here is I'm going to take the square root of the standard deviation of the amount of cars that are sold plus the squared, plus the standard deviation of the amount of cars that are leased squared, and when I add those up and take the square root, this comes out to be roughly 1.14. And then finally for part C, or number 3, the dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car that's leased. Find the mean and standard deviation of the difference in the manager's bonus for cars that are sold and leased. So the difference for this, I'm going to basically take, actually this shouldn't say difference, this should be the sum instead of difference. So to combine their averages together, so for instance, they were expecting to sell 1.1 cars, they were expecting to lease 0.7 cars. Here's the bonus for the amount of money that they get for selling a car, here's the bonus for the amount of money they get for leasing a car, and here's what the total value for that would be. And then finally, for the standard deviation, here is the amount of money that they get for selling a car. This is the standard deviation for the number of cars sold. This is the amount of money they get for leasing a car. And this is the standard deviation for how many cars are leased. And then here is what the combined standard deviation would be, 509.09. So as we kind of move through some other things that are involved with random variables, one of the things that we're going to revisit again have to do with some different things involving the difference between two random variables, and we're also going to do some different things with random variables that involve the normal distribution and the normal CDF.